Okay, so we're going to continue solving equations using our calculator. As you can see, right, these equations start to build kind of in complexity, right? But it's still the same process. Right? And the goal is to get our trig function, in this case sine, equal to some real number. All right. Now the goal is we have a 2 and then a 1/5 coefficient for the sine. Always work with whatever you're adding or subtracting first. Okay, so we'll start by subtracting 2 from both sides. Okay, so we have this going to 0. Pi over 2. And then 1.826 minus 2 gives me a negative 0.174. Okay, so the next thing is we need to deal with this 1/5 here, right? So what we do is we multiply by the reciprocal. Whenever you got a fraction, and even when it's not a fraction, like if it was just 5, we would divide by 5, but that's equivalent to multiplying by 1/5. So always multiply by the reciprocal. In this case, 5 over 1, or just 5. Right? So this reduces to 1. So we have a coefficient of 1. Don't need to write it. We just have sine theta plus pi over 2 equals to 5 times negative 1.74. Excuse me, 1.74 is what we have here. And that gives me negative 0.87. Okay. All right. And now again, this is within the domain of the arc cosine, right, or the range of the sine. In other words, right, those are equivalent statements. So if this is true, right, if and only if theta plus pi over 2 is equal to arc sine of negative 0.87. All right, excuse me, I ran out of room there. I didn't plan my real estate out properly there. But okay. All right. So now I'll use this in my calculator. All right. So we have arc sine of negative 0.87. And we get negative 1.055. All right. So we get theta plus pi over 2 is equal to negative 1.0. And I'll just go ahead and write as 6, right? We'll do a proper round here. Now remember, and again, here is where we have to do our interpretation here, right? Remember, calculator, fast, does amazing calculations, not very smart, right? And so we need to know how to interpret these results. So what we have here is we have this angle here, right? This theta plus pi over 2 to be 1.06. Okay, so the reference angle, okay, that's easy to find. It's just a positive value here, 1.06. All right, so that's going to happen, again, every 2 pi k, right, where k is some integer. All right, so the alpha reference, right, but where else is a negative? Now notice here, I'm not going to worry here about making this negative or positive. It's all going to come out when I plug in values for k. So I'll just leave it at that. Every 2 pi k, right, I get a solution, right? But again, that's not the other solution, right? Again, another thing we need to make sure we understand here, the other place, quadrant, excuse me, where the angle is negative, is where the sine value is negative, is in quadrant 3. And that is this angle here. Now remember, that is alpha r here, right? This angle here. All right, so my other theta plus pi over 2, my other solution to the angle is going to be pi plus 1.06, right? The alpha reference. All right, so this value is pi 1.06, 4.20. Okay, so my other value of theta plus pi over 2 is 4.20, right? Plus, again, that also happens every 2 pi k. All right? And again, in both cases, k is just some integer. All right, so let's work with one equation at a time here. So we have theta plus pi over 2 equals to negative 1.06 plus 2 pi k. And then I'll solve for theta here. All right, so I do that by subtracting pi over 2. All right, in this case, these are both negative. So here, I'll use the decimal approximation of pi over 2. Now, in your calculator, you can really just, oops, let's get out of here. You could really just plug in, so negative pi over 2 plus 1 or minus 1.06. All right, and we get negative 2.63. Right, and this we can just bring along. Okay. Now let's look for those values, right? Now looking at this here, right? If I plug in 0, I get a negative value for theta, which again, I don't want, right? I'm looking for values between 0 and 2 pi. And any negative value is just going to give me an even more negative theta. So right away here, I can see, all right, I should start at 1, right? Because 0 gives me a negative value for theta, which I don't want, right? I want it between 0 and 2 pi. So I'll start by letting k equal to 1. And here we have theta, negative 2.63 plus 2 pi. All right. And we give negative 2.63 plus 2 pi. And we get 3.65. All right. All right, so we get positive 3.65. All right, and that does fall between, between 0 and 2 pi, right? 2 pi is roughly, what, 6.28, something like that. Okay. All right, let's try for 2, but I got a feeling that one's going to be too big here. But here, theta, negative 2.63, 2 pi times 2. All right, again, let's simplify here or make it easy on ourselves, times 2. And we get 9.94, right? Right, which again falls out of our 2 pi interval. So we'll reject that solution. So we have one value for theta. Okay, so let's move on to our second equation. In our second equation, we get theta plus pi over 2 equals to 4.20 plus 2 pi k. All right, and again, I'll start by subtracting pi over 2. And we get theta is equal to 4.20 minus pi over 2. That gives us 2.63 plus 2 pi k. Right? Again, notice here when we add or subtract, we just focus on the like terms, right? As opposed to when we multiply or divide, it's the whole equation. Okay, and now again, right here, this step remains the same for however the function looks, right? We just plug in values, right? So when we start with negative 1, I can right away see, remember, 2 pi is around 6, so if I make that a negative 6, right, with k let it be equal to 1, we're going to get a negative value for theta, which I don't want. So right away I could see the negative values are not going to work here. So let's start with non-negative values, right, starting when k is equal to 0. All right, that's an easy calculation right there. That should be 2.63. And that's well within our range. So that one is good. And I got a feeling k equals 1 is going to be outside the our our range here. But let's plug it in here just so we can be sure. So we'll do 2.63. 2.63 plus 2 pi, and that's 8.91. And that is larger than 6.28, which is roughly 2 pi. So we'll reject that. So in this case, we only have two solutions, right? So my solution set consists of two angles in radians, one of them being 2.63 and the other one being 3.65. All right. And again, right, we did this work analytically. What would this look like? Just wanted to check our solutions. We can always get a graph going just to verify here. If we look at our graph, we could see there, right, our original equation, or not original, I should say, whenever we had it, sine x plus pi over 2 equals to negative 0.87. Looking at those values here, 2.62 and 3.65. Right, rounded to 3.66 on the graph, but again, whenever we're dealing with approximations of pi and stuff like that, there is going to be some round off error. Right? But again, here this wasn't more than 1/100th, so pretty confident that we did this correctly. All right, thank you.